Hello dear doctors, good day to all of you. Today I am going to discuss an important topics of physiology for MRCS part examination. The topic name is oxygen hemoglobin dissociation curve. Actually, the oxygen hemoglobin dissociation curve is something that sounds complicated, but it really is not. This curve shows us as how hemoglobin saturation with oxygen relates to the partial pressure of oxygen in the blood, known as simply PO2. Now, if you recall, one hemoglobin molecule can bind up to 4 molecules of oxygen. As more oxygen molecules are bound, affinity for oxygen increases, which is why the curve is S-shaped. Reading the curve is all about connecting the dots. For example, at partial pressure of oxygen is 25 mm of mercury, hemoglobin proteins might be 50% saturated, which is marked as P50. In arterial blood, while the partial pressure of oxygen is around 100 mm of mercury, hemoglobin is fully saturated, that is 100%. But in case of venous blood, when partial pressure of oxygen is about 40 mm of mercury, so hemoglobin saturation is about, I think now you have guessed it, was about 75%. There are some situations when the curve can shift to right or left depending on how affinity for oxygen changes. In an adult with hemoglobin A, when partial pressure of carbon dioxide temperature or 2,3-diphosphoglycerate are high or pH is low, hemoglobin affinity for oxygen decreases and the curve shift to the right. However, when partial pressure of carbon dioxide temperature or 2,3-diphosphoglycerate are low, or partial pressure of carbon dioxide temperature, or we are looking at hemoglobin F or fetal hemoglobin instead of hemoglobin A, hemoglobin affinity increase, the curve shifts to the left. Here's another picture given that when curve is shifted left and when curve is shifted to the right, you'll find hemoglobin braid such as fetal hemoglobin, methemoglobin, carboxyhemoglobin. Here's the curve is shifted to the left, and also in case of carbon monoxide poisoning and hypophosphatemia. And on the other hand, in case of right shift, here's pregnancy, chronic anemia, arterial hypoxemia, and sickle cell anemia. In this disease, curve is shifted to the right side. I think now I've got a clear conception for oxygen hemoglobin dissociation curve. Okay, thank you dear doctors.